Okay, you're live on the internet. Hello, internet.
Hi, internet. Okay, well, I'll start since we're live on the internet. Hi everyone, my name is Olivia Jack. I'm a programmer and an artist, and I'm the creator. For the last year and a half, I've been creating this software called Hydra that runs in the browser, and it's a way of making visuals using live coding, which I think the last talk gave a good intro into live coding, but it's writing code that generates music and visuals in real time. And after this talk, we're also going to have a performance with various people here involving live coding. And yeah, it was something I started making, and I put it on the internet, and other people started using it, but it wasn't something I said like, oh, I'm going to make a tool that lots and lots of people are going to use, and now lots of people are using it. But to me, it's kind of never finished. It's like it keeps growing, and keeps evolving and stuff. So it runs in the browser. Here, let me see. There we go. Yeah, it runs in the browser at this address, and if you go to this address, something like this will pop up, and if you close this window, then you see this kind of pretty visual thing, and then code on top of it, and you can switch and sort of see different sketches that other people have made. And there's these words on top, and this is code that generates the visuals that are behind it. Actually, can you see the code? I'm wondering. Okay, you can see it. Okay, cool. And Hydra, it's modeled on analog modular video synthesizers, and so maybe some people are familiar with analog synthesizers in the world of sound, but it's a really similar idea, the idea of modular synthesis, both in sound and in visuals. But basically, this is a video synthesizer created in 1971 by Daniel Sandin. It's called the Sandin Image Processor. And basically the idea is that each of these boxes either generates a signal or transforms a signal. And when that signal gets to the screen, it generates a pattern. And the signal generally is an oscillation in time. So if it goes to speakers, you can hear that as a sound, if it's within a hearable frequency. Or when it gets to the video, it sort of goes line by line and generates a pattern based on the signal. Obviously, I'm simplifying things here, but conceptually, it's a signal, and based on that signal, it generates something that you can see or hear. And each of these boxes then either generates that, it's changes in voltage over time, generates that or modifies that. And then the way that you maybe hook these boxes together can affect what you see. So, and the idea with modular synthesis is to think about how to design these boxes so that you maximize the kind of creative possibilities that there are in this. And I'm kind of being specific about this because I want to contrast it with other ways of making visuals on the computer. For example, Photoshop uses the idea of a photo, of layers and a photo editor, and you're sort of working with layers and drawing things onto a canvas. Or something like Illustrator is more vector-based, or even something like Word, there's this idea of a page and you're writing words on a page. But actually, to the computer, there's no concept of a page. These are things that as users and creators of software, we create and that help us think about the ways we're interacting with these things, and either expand or limit creative possibilities. another example would be 3D rendering software, where you have this idea of a scene, a mesh, and lights. And so none of those things actually mean anything to the computer when something gets to the graphics card. They're just things that, as users of computers, we create to understand how we interact with them. And so Hydra is inspired by analog video synthesis. And so it's this idea of routing signals into and out of each other. So if I go ahead and open the editor, I can get rid of what's on the screen through this, and then basically what I can do is I can start to type into this editor. And so one of the most basic things that I could type here is OSC, and that generates an oscillator. And on the computer I just press Control-Enter to execute the code. But you can see that nothing happens, and that's because basically I've created an oscillator, but I haven't connected it to any output. So in the analog modular synthesizer world, I haven't connected it to something where you can see what that signal is. So if I say out, and then I do Control-Enter again, now you can see an oscillator on the screen. And so each of these words in coding is a function, and it's very similar to this sort of, each of these boxes. So each word is sort of like a box. And so what I can start to do here, one thing, I can change parameters of this oscillator. So if I, for example, put a different number here, it changes the number of oscillations. And each time I'm just pressing Control-Enter, and it updates the code. And then, yeah, there's a few different parameters here. So, and you can think of the numbers as sort of like the knobs in a modular synthesizer. And then I could add. So I've created an oscillator. Now I could add more things to it. So I could say rotate. I could add a repeat. And so here I'm creating an oscillator, I'm rotating it by a certain amount and a certain speed, and then I'm repeating it also. Or another one I could do could be a kaleidoscope. And so, yeah, basically I can chain an infinitely number of these words within each other, and the order also matters. So maybe, what if I did maybe I could repeat before I did the kaleidoscope, and let's see what changes if I did like this. Yeah, so now. Or then I could rotate again. And then more things happen.
So it's repeat like a multiplier?
What'd you say?
The repeat function, is that like a multiplier?
Yeah, it just repeats. I'll show it just without everything. So if I did like 20 times, then it would repeat the same thing 20 times. It's a little hard to see there. Yeah, actually, yeah. So if I put like 20 here, then there's a lot more, or 2, then there's 2. Yeah, it's really fun. Yeah, and go ahead and ask questions as I'm going, because it's a small group. So. Yeah.
So I have a question as well, which is, when you were doing this, and obviously you wrote this tool, so I'm sure you know it kind of inside out, but when you're kind of creating these things, how much do you know like exactly what's going to happen? So for instance, you switch the order of two things there. How much, like in your head, do you know what's going to happen, or do you know roughly what's going to happen, and then as you're kind of doing it, it's like an interactive process, and you're like, no, that's cool, I'll just go with that, and then keep going.
Yeah, that's a really good question. And it's really interesting because I've built this whole software so I know all the code that's in it, but actually I don't always know what's going to happen. I actually usually have some idea, but I don't actually know what it, like I don't necessarily have the image in my head. And that's one of the things about live coding that I enjoy a lot, is being able to immediately see the results of this before. And I come from a programming background where before this I would excuse me. Where I would, you know, write a software and application and then compile and then realize, oh, there's this error, oh, this thing didn't work exactly how I imagined. And starting to live code, it's actually even changed my process for development projects outside of this, but just making things that I can modify them in real time and kind of emphasizing that both in my development process and creative process. Yeah, because I've still, even though I've made this thing, I'm still kind of learning how to use it. And so part of like sharing with other people and also being able to change things live is being like, oh, I really like that effect. I didn't imagine I could do that or something. Yeah, and so here we're using this thing called an oscillator as a source, which is something that goes up and down in time. But we could also use something like a webcam as a source. So in Hydra, we could do an cam, and then here I have. And this is just saying, like, make a camera in this thing called S0, and then here. Now I'm saying, start with that thing called S0 and send it to the output. And so there I am. And you can start applying effects also to my face. So like that, or we could do a color.
No, this is sort of real.
What did you say?
I just, you're rotating reminds me of Fresh Prince, the intro to Fresh Prince. Do you know the Fresh Prince of Bel-Air show? TV show?
The what? Sorry, I can't hear you.
I forget you're American, you probably might not know. Fresh Prince of Bel-Air is a show.
Oh, yeah, yeah.
Wait, it is American.
Yeah.
And just the music rotating reminds me of Fresh Prince.
That's great. Yeah. Yep. So, you can make lots of effects. We could do a kaleidoscope with this also. And so here we're only seeing basically one output, but in Hydra there's multiple outputs, and you can sort of route each of them into and out of each other. So to see all of them, if I do this function render, now I have various windows, and I can see each one. And so I could. Right now I'm sending one thing, which is like my camera, into that one. And then each of these outputs sort of have names. So like this one's O0, and then I could do another one, send an oscillator, and that would be sent to O1. So now I have kind of two different visuals going on. And now that I have these two things going on, I can start to mix one with the other. So we could do something like take what's in O0 and mix it with what's in O1 and send it out to what's in O2. And so here there's this sort of like mixing thing happening. And there's different ways of mixing these things together. So, yeah, based on, and these are each taking each color at each point and either combining them, like adding them together, or what do I want to say? Actually, this is what I want to say. Has anyone seen something like this before? This image, this. I was gonna ask what do you think it is, but I labeled what it is, so that's a bad question. But this is a close-up of an LCD screen, and so what most computer screens are at some point. And so if you look really, really close, it's this array of lights of blue, green, and red lights. And so each combination of these things together, of 3 LED lights together, makes a pixel. And so if you really zoom out of it, it kind of looks white. This on the right is the same image as on the left, but just really zoomed out. And so red, green, and blue all together, if all 3 of them are on, when you're really zoomed out, it looks like a white light. And then if you turn the green off a little and leave the red and blue, you get sort of a magenta color. And so a lot of different ways of working with graphics on the computer. You have this concept of red, green, and blue channels, but this actually corresponds directly to how the LED lights in the computer work. And so I'm mentioning this because with Hydra, each function is directly telling the computer what color to make each of these pixels. And so when you combine 2 different things together, it's different ways of sort of combining these pixel colors together. Does that make any sense?
Yes.
Okay. Yeah, because it's a small group, feel free to ask questions and stuff as we're going. So when we have something like this, and here I'm combining these 2 things together, it's actually going pixel by pixel in each of these 2 images, and saying, okay, how red is this? How red is it here? How red is it here? And taking the difference of those 2 values, and that makes this visually. Maybe I'll actually show this a little more. So I could do a really simple color. So like solid 0, 0, dot out. And so that's red. I just do that. And I could do another color, just like solid 1, 1, 0. And so here we have red and yellow. And these are just saying turn on the red LEDs in all of the pixels. And here it's saying turn on the red and the green. And red and green actually with light makes yellow. And so here, if I say start with this one, source S0, and then I say add it to this one, add it to O1, and then send it over here. Whoops, this video, that took my camera stuff. That's a bad example, but what it's doing is it's taking this one, it's adding it to this one, it's taking the 0 and adding it to this one, and it's taking the 0 and adding it to the 0. So this color ends up, because 1's the maximum, it ends up being 1, 1, 0. But if I change this here, for example, so I put, so now we have red and blue, so it's adding 1 to 0. It's like performing basic arithmetic on each of the pixels. And I mention this because it's a pretty direct way to think about color in terms of the computer. These are actually just LED lights, and when we're programming the colors, we're actually telling each LED light which color it should be. And so if I do something like difference, let's see, or I'll do multiplication. So any guess then, actually, what color this would be if I'm going to multiply them together?
Black.
Yeah, someone says black. Any other guesses? Purple? So let's see. Yeah, so it's close. Actually, if I didn't fully multiply it, I think it would be dark purple. So, okay. No. But yeah, what it's doing is it's actually just multiplying each of these values with each other to create that. And so if you've used to create that. And so the second value is how much to multiply them with each other. And if we did something like, if we did something like this, I think it would be purple. Let's see. Like that, yeah. And this is used in a lot of software, like video editing software, Photoshop. You have blend modes and how different layers get composited on each other. And all of those are just simple arithmetic of pixels, basically. And so going pixel by pixel and saying what color is this pixel, what color is this pixel, and what color should the output of this pixel be. And so that's like one way of combining different visual sources here. So I'm going to go back to using the camera because it's more fun. So we'll go back. Source. There's the camera, and here I can have an oscillator, for example, with some color. And so another way, one thing that I was interested in Hydra was, again, going back to analog video synthesis, and one of the things, and I actually have never had very much access to hardware for doing analog video synthesis, but I was really interested in experimenting with it. And so one of the reasons I started creating Hydra was that I read about it, and then I wrote software to replicate the things that I read about, because like these can be thousands of dollars to actually get equipment, but I wanted to kind of experiment with some of these things. So another thing you can do with this is something called modulation, which is using, instead of combining the colors of two things, it's using the colors of one thing to affect the coordinates of the other thing. And so it sort of ends up being like a warp kind of thing, so like this. So here it's using the colors over here, that red and blue, the first channels, the red and blue, pixel colors, to sort of warp this thing over here. And so then I end up getting this like wavy thing. And if I start to change this, then we start to get this it updates all of them in time because it's sort of this like routing thing. Any questions about that?
Have you written all of this using JavaScript and that's quite impressive.
Wait, sorry, what'd you say?
Have you written all of this using JavaScript and
It's all running directly on the graphics card. So each chain of function renders to a shader, which is a program that runs on the graphics card.
So you're using WebGL?
Yeah.
Oh, okay.
Yeah. And just in more, so a shader is just a program that tells the computer, literally it tells the computer what color each pixel should be. And so it runs, the program runs simultaneously on each pixel, and it tells the computer, this pixel should be this color, this pixel. And when you use other kinds of software that have text or all this stuff, that all happens on the CPU, which is like a different processing thing in the computer. And that gets sent to the GPU, and the computer then uses that information to decide, oh, this was text here, so this pixel should be this color, this pixel should be this color. Doing something on the GPU is different because you're just saying what color should each pixel be, and you're kind of directly using it, if that makes sense.
Can you use other inputs that aren't like visual, like can we get like audio?
Yeah, I'm going to show that in a little bit. So, yeah, I'm going to show that in a little bit. And so, also, here I kind of was rendering all these things in separate places. But I could also do the same thing, just all in one line of code. So I could, for example, I could say, I'm gonna make an oscillator and send it over here. Over there. And yeah, the reason, what I can do right now, I'm doing Control Enter, and so that's executing different lines of code at a time. So in terms of doing something live in front of people, that lets me say, oh, I want to like easily do turn something on or off or something, so I can have the code there and switch between it. So here I have an oscillator, and then I could say, oh, I want to add my face on top of it, because why not? So I could like do this, and then directly send it to there. And so I don't actually need to do this whole step of like sending it to that output, sending it to that output. I could just keep, and then I could say, I want to multiply it with another oscillator that has a color. And then I could get this, so just show this one. So here, there we go. Yeah, and then we could modulate it with another oscillator. And then we could rotate this one. Yeah, and so you can just keep adding more and more things within each other.
I mean, I love it. I'm going to try it tonight. What's interesting is that I'm not able to, I have a question about whether it's what you're doing is creative or whether the output is creative. Do you see what I mean? At what point, for example, would what you have on screen become art?
Yeah, I don't know the particular answer to that question.
What were you trying to do?
Personally, I think I had a lot of, the most creative piece for me is the creation of the software, and then my explorations, my visual explorations with it are sort of an exploration of that. But I think it's an ongoing process, if that makes sense. And one of the things that I've kind of become completely fascinated with this is the idea of feedback. So it's when the output of something becomes the input to itself again. Actually, okay. So. One thing that this idea of routing things makes really easy is to play with feedback loops. So I'm going to start over again. And this time I'm going to use a webcam instead of this camera that's here. So we could do something like, and it should be like that. And show the camera. And so here I have this webcam. And if I take this webcam and point it at itself, then it makes this sort of thing. And so, I can get already some. And so what's going on here? The camera is looking at the screen, and then it's sending the image of what it sees to the screen, which comes back into the camera, which gets sent to the screen. And each time, I can't hold it exactly still, so each time it changes a little bit. And so those changes kind of make this sort of spiral thing, or they make like this sort of endless tunnel effect, or all these different things. And so this is a really interesting, I think, thing to play with. And it's hard with this camera. You can see that a tiny change, because it gets multiplied infinitely, has a really huge effect. And so playing with the same idea, but in Hydra you can play with it directly in the code, like without using a webcam, can then make it sort of easier to play with some of these things that are complex systems. And actually I want to show a short video really quick. Let's see. So this video is by someone named Jim Crutchfield, and he made it in 1984, and he's a physicist and also a video artist. And he talked about this system, just a video camera pointed at a screen, and he talked about this system as a computer capable of doing certain types of complex simulations. And so, and it's actually a good way of modeling differential equations, because a differential equation is kind of a system that has a certain state, and then each time it updates itself, it's a tiny modification of that state before. So that's the same thing that we were just looking at with the video thing. And so here he shows his studio, some nice 80s music.
Is this on YouTube?
Yeah, it's on YouTube, and it's a video and also a paper that's space-time dynamics in video feedback. And so in the paper he goes into the equations that, the differential equations and stuff, and then in the video he shows kind of different emergent behavior that can happen from this. And to me, it's interesting both in the idea of that this is a computer without being a computer that you could program, but that this thing just with a screen and a camera is a computer in a certain way, and that actually until really recently we can do these things with modern graphics cards, because they're really parallel complex operations. It's something that's hard for a CPU to do in this sort of visual way. And so here he goes through various sort of different examples. I'll just show a few of them. And so this is all just a camera pointing at a monitor. The music isn't coming from the camera. And so I'll show a few examples in Hydra of doing similar things. So here we have, I'm actually going to switch to the other camera. So here we have this camera. And I could, for example, blend it with itself, blend the output with this input here. So right now, nothing really changes. Like, basically, Oh, whoa, there's actually feedback with the projector too. Anyways. So I'm starting with the camera. I'm blending what's going on with the output. And then I'm sending it to the screen. If that makes sense. And then I do that again and again and again. And here, because I'm basically blending this image with itself, you don't see any difference. But if I say I put this all the way, I basically only show the past image. So this second parameter is saying how much to blend the first thing with the second thing. So it's saying take the camera, blend it with what was on the screen the frame before, and then send it to the output. And if I say 1 here, then it's only going to blend it with what there was before. So basically it's only showing what there was before. And if I put 0 here, it's only showing what's on the camera. And if I put like 0.999, then I get this like kind of ghost trail thing, because each time it's just slightly blending it with the new image. And so if I combine this with, remember with this camera, just really slight changes start to have a big effect. So if I combine this thing with just a slight thing, like I'm going to make it a tiny bit bigger each time, then we get these like, it's kind of hard to see there, then we get sort of a zooming thing. I could add more contrast maybe, that now we see it a little more. So there, get this sort of zoomy thing. Right,
Looks
okay.
like Doctor Who.
What did you say?
So it's loads like Doctor Who now.
Yeah, it's very, or this combined with the modulate thing, which is again using the colors to modify the coordinates. Let's see. Then we get start to get some sort of liquidy things. And this is actually really similar to the equations that people use to model fluid dynamics on the computer, where they calculate sort of pressure and velocity at each point and continuously update it. And so one thing that's interesting to me is these things that are supposedly like really, really complicated math topics are things that also we can play around with and sort of intuitively understand without saying, oh, I have to know every calculus equation in order to play around with this, because I think some of what makes a certain topic more technical or more complicated is just that the ways that we've taught them and the abstractions that we've created to get there. And so in another software it might be really complicated to play with fluid dynamics, but in something that's based around feedback it might be a simpler, in quotes, thing, because like what's simple? Or so another example that's sort of using feedback is something like we could do a shape and send it to the output. So here we have a triangle. And so I can now blend the output of this with the input. So I'll actually add it this time. So add O0. And so nothing changes because it's a triangle, and then I blend it with a triangle, and then I blend it with a triangle. But if I actually repeat it each time, so here now I'm drawing a shape, blending it with what was on the screen before, then I'm going to repeat it 4 times, or twice and twice. I haven't executed the code yet because I want to explain it before I execute it, so you can try to imagine what might happen. So I have the shape. I'm going to blend it with what was on the screen the time before, and then I'm going to repeat it 4 times. Oh, I'll just show you what repeat. This is what repeat does. So that's what repeat does. So, oops. Oh, I just showed it. There we go. So I'll show it again. So I have the shape, and then it can repeat it. But if what I do is I draw a shape, then I add it to the screen before, and then I repeat it 4 times. So now I have 4. I draw the shape, I add it to the screen before, then I repeat it 4 times, so now I have 4 times 4. Then I repeat it 4 times, 4 times, 4 times, 4 times. And so then it keeps going like that. And so it ends up looking kind of like a fractal, which is something that repeats itself at each different scale.
What's the bit of code that loops it infinitely like it?
That's just this feedback loop.
Oh, okay. Oh, so what is that? The shape bit? So what's doing that in your code at the moment? The feedback loop.
The feedback loop is this. So this output is becoming the input again.
Right.
And there's basically each time this code is executed, the computer updates 1 frame. So there's like a slight time difference. So it's using what was before. Does that make sense? Kind of.
But it's stable now. It's not moving.
Yeah. Yeah. So,
Is it an infinite loop?
yeah, pretty much, because it's just the output, the input. So if I actually, that's interesting. If instead of repeating this, I just made it a little smaller, let's say. Oh, actually we won't see anything, no. I'm trying to think. I mean, the triangle staying still, so then each time it gets to a point where it's so small that we don't see it anymore, I think.
That's what's happening.
I think if I did something like, let me see. It's taking the opposite of itself, the difference of the previous image, so then it's continuously flashing. I'm going to get rid of that because it's really flashy. But then it's not stable because it's like changing each time.
Nice.
Yeah, and so for me to play with these sort of more organic and chaotic systems, where you even, I've spent a lot of time like writing the software, and I know what code is under it, and I still don't know what's going to happen. So this idea of live coding as this constant process between myself and the computer that can continually see what happened and how did I change it, is the live coding aspect really helps, because if I had to write a bunch of code and then wait for it to compile and then go see what happened, it would be a lot harder in terms of a creative process to know sort of how these things work. And so, actually, I guess, yeah, these are some things made in Hydra. So this is in Hydra, but it's similar to something called a reaction diffusion that is a way of modeling how like chemical reactions diffuse in a system. And then this is something that Daniel Sandin said, the creator of that that video synthesizer that I showed at the beginning, that he made in 1971, and one of the things he said is, he talks about the difference between real-time information processing versus stored-time processing. And obviously here he's talking about analog hardware and stuff, but he says, put yourself in a feedback loop. Yes, the reason you put yourself in a feedback loop is so you can learn something, or rather learn to do something. You know, you do something and the results get processed somehow, perhaps just by you yourself looking at it, and you do another thing and the results of that get processed. And your action can constantly be tuned or corrected or refined by what you see. And so, yeah, it's this idea not just of a feedback loop as like a sort of aesthetic thing, but as also a creative process. And I also like it if there's like no starting point and ending point in a certain way. And so that fits into how I feel about the creation of the software as a whole. Or one of the even things like, when you go to the editor, you see already something in it. Is like your a lot of times with software, there's this idea of like people who know everything, and like the software developer who like just knows everything. This like mythical software developer or something. But really, everything in software is like built on something else, and so there's no idea of like starting completely from scratch or something. And so something that I've been exploring in this idea is like everyone's like learning from each other a little bit. And so also here there's this there's a button. I'm just gonna change this a little. Let's see how to change this. So there's a button here to share, and so I'm just gonna say no bounds, no bounds. And so there's a button here to share, and then what happens is that this goes immediately to a Twitter bot called Hydra pattern, and I'm actually mostly just using Twitter for free hosting. Oh, it hasn't loaded yet. So this sketch that I just did then showed up as a thing in this Twitter, and so other people, we can see stuff that other people have done. And actually, if you click on a link, then it directly opens the editor. It's a little slow, it seems right now, but it directly opens the editor with the code in it. And one of the things for me that's been interesting with this is that even though I've made this tool again, it's like an ongoing process of learning how to use it and stuff. And so seeing how other people use it is a cool way for me to kind of see other possibilities with it, and to think of it as this sort of growing thing where we're all like doing little pieces of it. I don't know why it seems to not want to load. Any other questions?
Well, can you output that stuff to the sound code? I don't know if it would work.
Oh yeah, that's what I was gonna talk about actually.
Okay.
Thank you for reminding me. I'd forgotten. So you might see here actually that there's you can see some sound information. I don't know why it seems to not. Yeah, maybe the internet went down. Okay. So, anything in Hydra that's a number, it could also be a function. And so a function, in this case, it's a little piece of code or logic that outputs a different number over time. So the number can be variable over time. So let's say I have a shape, and I could say in the second parameter of this is how big that shape is. So if it's 0, it's really small, or if it's 1, it's really big. It's like 0.5, it's like this. But I could say instead of always having that be 0.5, I want that number to change. And so then I can write a function, and let's say, I want it to change with the mouse or something. So I'm going to say the x position or horizontal position of the mouse is going to affect the size of this. And so now, instead of it being one number, it's a different number depending on, at a given moment, where my mouse is. But I could also use that to make it correspond with the music. So here I have the Fourier transform of the sound, which is kind of showing levels of sound at different frequencies. And so the left side is low frequency and the right side is high frequencies.
What's the latency like if you were to start programming stuff to display based on what the microphone is picking up? Is it pretty good latency? Does it do it like instantly, or is there a little bit of a delay to it?
You have to try it and see, I guess. I mean, nothing is instant,
Yeah.
but we can see. We'll see right now, I guess. So here, the way that I refer to this first band would be like this. So it's really, you can see tell it's pretty jumpy. Like if I wanted it to not be as expand as much, I could like multiply this by something so it's not it's a little smaller. And then if I want it to be not quite as sensitive, there's a parameter that's like smoothing the audio input. So I can do something like this. So now it's going to have a little more latency, but average the values over time. Versus this way, it's more instant. Of course, nothing's completely instant, but I think at some point you can.
Like a refresh rate almost.
Yeah, and generally like 60 frames a second or something is a common refresh rate.
Yeah.
Let me see if this shows. Okay, so now one of the ones that I clicked on Twitter opened in the editor, and so what I can do now is immediately edit this code. So I opened up code that someone else made, and now I can start changing it. Let's see. And then if I get to something I like, I could upload it again. So let's see. Number 2. and then it shows up. Here. Yeah. And then it doesn't just show what I just made, but it says it was based on this other thing. And yeah, that to me is something I'm interested in. It is also to your question of like being creative, or like at what moment are you being creative and stuff. Because I think a lot of times some generative art, it's easy to like copy and paste code and then make this like installation. Oh, I made this installation, which is really great. But also a lot of this stuff with software is like we're all learning a little bit from each other, and it's interesting to me I don't think there's anything wrong with that. I think that's amazing, but then it's just to sort of trace the ways ideas pass from one person to another. And I've actually seen people perform and like cite other people in their code, which is kind of interesting. Like say, this piece by so-and-so or something. And I don't think there's like necessarily a black and white thing of like, when this happens, or this is yours, this is mine. It's more of like an ongoing negotiation. I wanted to show. Yeah, another thing. So you could actually use in other sources that you can use in Hydra. There's the camera. There's sources within the software, like an oscillator or a shape. You could also use a video, a photo, a canvas element. But you could also, in addition to cameras, you can use other windows. So you could do it's in its screen, like that. And so now it says pick a tab or a window. So I could actually pick my Twitter as the input here. Oh, where did it go? Here. Okay. So now, actually, okay, so we can see them both. Oops. Okay. Here's my Twitter. Here's my Twitter. Oh look, it's a Twitter of the stream. This is, now we're being self-referential. Oh yeah, I could use the live stream as an input. Okay, so I have the Twitter, and now I can say, use that. So now this tab is a source for the visuals, and I feel like I don't know, just do some funny things with it, or, add feedback maybe. So. And then modulate. Oops, that's a lot. Oops. Let's see. So now I like have this weird. Can you see that kind of? Yeah.
Yeah, yeah.
Yeah. So I can get this kind of weird. And yeah, you can have multiple windows like kind of feeding into each other, and that's one thing that's interesting to me is like thinking of these different windows as like also video synthesizer. Like you're bouncing videos around. Yeah. I think then we can just have time now for more questions or to try some things out. I think it's about the end anyways. But thank you everyone for coming. And yeah, if you want to try out some code, I think, because this was sort of like half workshop, half talk, if you brought your computer, you could take it out. Otherwise, we can also try stuff on my computer. Yeah. So thank you.
What we did yesterday, those little columns up on that.
Which thing?
The long, the squares, the
Or wait, one sec. Any questions, like general before? Or yeah. Sorry.
So, I was just remembering, and can you just import like files and stuff of it, or does it all just be online?
I forgot to mention this. On the online version, it's harder to import files. You can use stuff that's already hosted online that doesn't have restrictions. So like Internet Archive videos and stuff, you can directly use it. But there's also a version that you download that runs in the text editor called Atom, and there it's easier to use like videos and stuff like that.
It's called Hydra, right?
Yeah, it's called Hydra. Yeah, because you came a little late. Right? So there's like the website is Hydra Editor, so it's like Hydra Editor like that. Yeah. So yeah, it all runs in the browser, so you just open the browser.
Is there like I'm guessing maybe that's question mark, but is there like a documentation page where you have all of the...
Yeah, so that's also a work in progress constantly, but what did I do? So there's a GitHub repository, and there's some tutorials, and then also there's like a complete list of all the functions, or mostly complete list. Yeah.
With the audio, is like the microphone the main thing, or if you use something like Soundflower or something where you change the output on your computer, like can you input?
Yeah, I mean the easiest is to use Soundflower to have sound be input as a microphone.
Okay. Is there like, do you have to like write some code to change like the input within Hydra?
Yeah, actually right now there's in Chrome you can select it usually in it's like part of the browser. Where is this? Like right here you can usually select which microphone in Chrome.
Yeah.
But there isn't actually a way in the code to set it. Yeah, and we're gonna have a performance next, and I'll be using Hydra, so you can see it in action. Anyways, thank you all for coming. Yeah, if you want to come up here, I guess, if you want to keep looking at stuff.
I'll just be the first one to get it.
Should I take some first?
Yeah, do it.
Although am I now at Kelham? Like,
Yeah, maybe you are like but yeah, this is like the end of
Can we stick around there?
the. Yeah, but you can stick around and play around. Yeah, shall I use them for sound as well? Yeah. What's your name? Adelaide.
I'm not sure it's something this way, but probably she uses it.
Yeah, do you know if there's Wi-Fi?
Yeah, there is actually. It's right there.
There's lots of that.
Oh. Yeah, it's the same. That one. It's called something from the
Same place.
Is it working for you? Is it working?
yeah. I wanted to do this thing that you were doing before, the feedback,
Oh, cool.
but I can't remember.
Maybe actually there's one example that's a particularly good one.
So these examples in here, they're like a select
Yeah,
view.
I've wanted to. I haven't updated them.
So then it just automatically comes from the Twitter.
No, it doesn't come from. There were ones that. Well, this is the feedback one. But let me see. There's this one.
Is it like random?
Yeah, it's just not showing the one that I want right now. Oh, there. Okay, this one. So here it's like, what you can do, so this is a comment, so that'll get rid of the line of code, and Alt-Enter executes it all. So try just changing numbers here and pressing Alt-Enter.
Did you always have?
Yeah, mostly.
How did it take?
Like the initial thing, a month, but then it's never finished.
Yeah.
So my whole way.
Sounds yeah, I've seen them use like some programs before, like there's loads of different
Like for like vision. Yeah, like which like.
I'm not entirely sure. I've been to a couple of other actually.
Oh, yeah. Here in Tokyo.
Yeah.
Sometimes someone in the world uses Hydra.
Yeah, maybe. I'm not sure.
Yeah.
I know the guy called Sam.
Oh, Samson has used it.
Yeah.
I don't know. There's some other programs also. Yeah, some people use like Kodak or there's something called Serial. Another thing called Live Kodak.
Yeah, it seems like there's a lot of like music in the forms as well.
Yeah. Yeah, and so Alex, who will be playing later, he wrote one called Serial. That he'll be playing.
I see.
It's not your internet?
Well, the internet is kind of
Yeah, I think it's just the internet. It's just, I think it's loading.
Sometimes it just drops out.
Did it work